we need our leaders to be brave and bold to solve this problem. And in this room, we have our current leaders in our country in construction industry, and also we have future leaders. We have a lot of students here as well. So hopefully we can give them our insights and our expertise so they can take those back home and they can be that bold and brave leaders in our country. So hoping that, let's get started with our introduction. So we have really great experts here on the stage, so I'm so happy to have them here. And let's take just 1 minute per person, just introducing yourself and who you work for. And Kevin, you already kind of did, but let's start with Kevin again.
So I'm Kevin Kamsher. I've worked for the General Services Administration for 42 years, all of that in the building business. And I started working on sustainability in 1984 when we first encountered the idea of a sick building syndrome before we even knew what that was.
Yep.
I'm Jaap Hoogeling from Netherlands. I work for Dutch Building Services Research Institute for also more than 40 years, so that's a nice number. And when I started it, the first energy crisis was already emerging, and that was, you could say, a line through my total career from first guidelines and tools for our Dutch market to the European market, and now I hope also rolling it out to a global level. Give the building industry the standards, the guidelines they need to develop further on the sustainable building development.
Okay.
Yes, I am Shimamura of Taisei Corporation. Thank you for giving me this opportunity to join this discussion. And a couple of years ago, I visited Seoul to do research on zero energy building by visiting National Environment Research Institute and Green Tomorrow. I would like to introduce Taisei Corporation to myself. Taisei has 14,000 employees and $13.7 billion sales in 2015. We have various kinds of projects, such as buildings, dams, roads, bridges, tunnels, hotels, and so on. And I joined Taisei Corporation in 1974, more than 40 years, good number. There are 930 architects and engineers in design division. I have 30 years of experience in HVAC, it means heating, ventilating, and air conditioning design. As the Deputy General Manager of Design Division, I was in charge of mechanical and electrical departments. Thank you.
Annie?
So I'm Annie Pierce. I'm an associate professor of construction at Virginia Tech. And if we're speaking of the last 40 years,
40?
I've had the opportunity to experience some of the negative impacts that we've heard about so far today. And I really started to work in the field of sustainable construction in the mid-90s, when we realized that it was very important to start understanding how we could measure our progress. And so since then, I've looked at measuring sustainability as a concept and done a lot of research in the area. So I'm pleased to be here today.
Good, good. Well, today, our title and the term that we're going to hear a lot, and we already have actually, is this climate change. And probably in my mind, at least, the climate change is that term, image of that term is very gloomy, disastrous, and also chaotic, right? But today I'm hoping that we can actually present more like opportunities instead of disasters, and also we'd like to present more like chances that we can improve. So let's, before we even get started, I just want to set the tone that we should be like very positive message for the climate change. Okay, so although my image over here is still kind of gloomy, I just want to make sure that we stay positive for the entire day. So this climate change, just I want to ask you, each of you, kind of from the big picture or kind of 30,000 feet level talk, how this climate change changed your personal career or your job or even your organization, how your organization practices. So if you can just tell us, taking a little bit of time, how that climate change in general changes your life. I mean, you've already mentioned like 40 years a lot of times, when I was in elementary school 40 years ago. But how would you describe those? So Kevin, can you start with that?
Well, I think like Yap, the first thing that hit us was actually the first energy crisis. But the important thing to remember is that was an energy crisis. It wasn't a crisis of climate change. I don't think actually that we began to understand the severity of climate change until the early 90s, the mid-90s.
Yes.
That's when GSA began to adapt sustainable building practices, sustainable design practices. We began to look at how we change the design of our buildings. One of the things that we noticed in the 90s was that the buildings that we built in the 90s were not as energy efficient as the buildings we built in the 30s, the 40s, and the 50s. And that was a startling. Now, we knew, of course, that the buildings of the 70s and 80s were terrible, but they didn't get that much better in the 90s. And so that was our real call to action there. And then the second inflection point was with President Obama and the absolute focus on climate change from the very beginning of the administration, in cabinet meetings, in the deliberate measurement of what every agency was doing, number one, for mitigation, number two, for midterm resiliency against the effects, and number three, for long-term adaptation to the long-term effects, including things like passive survivability.
Well, to continue on this and reflect on this, it was also my experience after the 70s when there was an energy crisis. It was more about we were afraid that our energy will run out because of political reasons, but also in practical sense. So the first task I had is to develop procedures for the Netherlands first to make energy efficient buildings, and then it was, I think, the phase of the Netherlands to be an early adapter, so make rules to make energy efficient buildings. If I look back and say, well, okay, we did what we could do at that moment, it should be energy efficient, but it should also be cost efficient. And that was a limitation, always. And later on, as you look back, you say, we didn't do enough. Now we have a lot of pressure of climate change and also more political will to adapt and to change the rules. And that was the next step to develop those procedures also for Europe. And the European Commission asked me to coordinate work on five different technical committees in the European Standard Organization, where you have to, and that was a very difficult task, to plea for a holistic approach. So committees who are used to work on just thermal behavior of buildings, just heating systems of buildings, just cooling systems and ventilation systems, or control or automation systems, or lighting systems, they have to work together. And that was a very interesting task, let's say. But that was the first generation, I achieved in the beginning of this century. And after that, after the more severe will also in the European Commission to do more on climate change impact, we got a second mandate, a standardization request to the European Standard Organization to develop a more, I could say, holistic, but also a more usable system that could be adapted by the regulators in the different European countries. Because as we as engineers just make standards, make procedures, they are not always that suitable for regulators. And that was our main focus also in this second generation that will go out for final vote in 2 weeks' time. And that really changed my career, you could say, focusing first in the start of my career just on heating, ventilating, and air conditioning systems as mechanical engineer, to finally a person who is coordinating work around standards. I didn't think about that when I started.
Would you please speak for me? Can I ask you? Yeah. Okay.
Yes. Okay. For the pressure from you.
Yeah.
In 2009, Environment Division was established for a sustainable society where people can adapt to climate changes. And this is, I say, organization chart. My role is to coordinate related divisions to develop low-carbon-oriented projects. The organization chart in the light blue color, Design Division, Technology Center, Marketing and Sales Division, and Building Construction Division. These are major divisions which I closely work with. Next, please. In Environment Division, we have 3 main businesses. For the smart community, we are developing technologies to optimize the energy utilization in the community. Zero energy building, ZEV, is the ultimate goal of energy efficiency. And also biodiversity is also important to the climate changes. And the third one is soil remediation. That's why we built the new division.
Okay, the next one. Yes, I have.
Or, yes, this is the Japanese energy consumption data since 1973. Industry sector is decreasing slightly as they improved energy efficiency of the plant. But the building and housing sectors are increased drastically, more than 2 times. So this is the market where we need to reduce CO2 emissions. That is why I'm focusing on zero energy building and smart community. Okay.
Annie?
So I am unique among the panel in that as a faculty member at a university, I have the opportunity to work with students. And I have to say that the current generation of students have a very different perspective on climate change than their parents and their grandparents. And so I see my life has been very different as I watch students come to university and learn ways in which they can actually make a difference. So while I've been at Virginia Tech, for example, a student-led effort has been undertaken to get the president of the university to commit to a climate action plan. And the students themselves worked with faculty and the local community to develop the plan to inventory the university's carbon emissions and to develop reasonable estimates of ways that they personally could reduce the climate impact of the university. So that has spawned all sorts of interesting investment programs by the university. There is, for example, a grant program where students who are interested in making changes to campus, say through implementing a new technology in a dormitory or maybe changing the kind of food containers that are used in dining halls, they can make a proposal and actually receive a grant to implement those changes and to measure the outcomes, to measure the differences. So I've been very honored to watch the younger generation, many of you are out in the audience today, to watch your generation be very aware of this problem and be very creative in some of their efforts to try to address it.
Mm-hmm. Yeah. I actually, just to add to that, I saw this study done and published by Harvard University Business School in 2015. They surveyed a number of different generations and how they consume their money when they buy products or buy services. And the Generation Xers, for instance, like they were considering the sustainability of the product or sustainability of the service providers. Only like 18% of them are concerned about the sustainability when they make a decision on purchasing. On the other hand, the millennials, which is from 21 years to like probably 33-year-old right now, that generation, more than half, 51% of millennials are very concerned about sustainability, and when they buy products and services, they actually look at that. So they are future consumers of our world economy, right? So I know there are several business folks here, and when you do your practice and you want to sell apartments or buildings, and those millennials look at how green those buildings are and how green those apartments are. So I think just it aligns with exactly what you said, right? So I'm so glad that you mentioned that. So, well, let me actually show you this. If you look at the screen, number 21. We are all kind of environmentalists and or very heavily sustainable oriented. So what does this number mean to you? By the way, first thing hit your brain is what?
It's the legal drinking age.
You got to use the microphone. Yeah. I mean.
So just to clarify, it's the age at which in the United States you gain a lot of additional responsibility and privileges of a certain type.
By the way, to clarify, we as a panelist, we kind of exchanged what we are going to talk about today, and we had these slides kind of sharing each other. I didn't share this slide with these guys. So they didn't know, actually, I had this quiz for them. What else? I mean, these days you hear a lot, number 21. What is it? No idea?
Well, it's the century we're in.
Exactly.
It's the century we're in, and it's the century of the inflection point on climate.
Mm-hmm. All right. Actually, even your joke about this drinking age, 21 is basically like, we consider that as a responsible adult, right? Well, they are our, as I said at the beginning, they are our future leaders, right? So very important for me that age is also. What else? I mean, even the audience can answer this, probably. Well, you actually heard this number several times already from the minister. One is COP number 21 was approved last year in Paris, which is a very critical milestone in our history. And she showed this chart starting from 1992 to COP21, okay? And in 1992, she said that was the beginning of this environmental talk at the UN level by UNFCCC. And out of that meeting in Rio, Brazil, what did that come out? It was Agenda 21. So we now have this commitment by 162 countries, but back in 1992, we had this agenda for 21. And why did they call it 21? Because they were looking at, your answer, 21st century. So I just wanted to emphasize again one more time, from our talk, we are talking about this future, and we started this talking at the global level, about 25 years ago, 24 years ago, and they were looking at this century that we are in right now. So if you look at, how much we've achieved since that Agenda 21, and we are now into the 16th year of 21st century, and let's look at the next 21 years. Sitting here, and let's just talk about what we're going to see in the next 21 years, okay? That's kind of how I set today's discussion. So, I'm also a professional expert in the United States, practicing architecture and green building consulting, and also I'm a faculty for U.S. Green Building Council, so I do teach a lot on LEED around the country, sometimes in South Korea as well. And, from that point of view, I see kind of three mainstreams in the green building movement. And one is, of course, we talk about low carbon economy a lot these days. And second thing I noticed these days, is kind of health and wellness of the building occupants as well. And then the third one that I hear recently, especially a lot in the United States as well as around the globe, is resiliency. So let's frame your answers with my next question within these three categories, and then I'm going to start with my questions. But before I get into those bunch of questions, I just also want to ask you to think about this challenge that we face all the time, which is, there's urgency of this climate change in South Korea as well. So everybody knows what we need to do or what we have to do, but then when the government sets policies, for instance, then the market's reaction, instant reaction, typically is, oh, we are not ready yet, or we don't know how to do it. So we have to balance sometimes the market's readiness versus the urgency. But if you listen too much, what market says, then probably you cannot really address the urgency. So, I think this is a challenge for the policymakers, like some of you in the audience, but also this is a challenge from the practitioner standpoint as well, because I'm the market, actually. So, again, when you answer your the questions I'm asking, so please keep in mind this challenge and how these people can address this challenge as well. So I want to just start with Kevin, again, going back to you. So my question for you, Kevin, is, so you kind of briefly talked about what U.S. government does, also what Obama administration has been doing. My question is more like how you make decisions and policies related to construction and built environment to boost those three frames. So when you make decisions, how do you consider this low carbon economy and also people's health and wellness, and as well as preparing for the natural disasters?
It takes a large team of people working together to make those decisions effectively. Mm-hmm. So what I'm going to start with is something that got brought up just a few minutes ago about cost, because I think you didn't mention specifically, you said the market might say we're not ready. I think the most common thing the market says is it's going to cost too much. Mm-hmm. So when we looked in 1996 at the differential, the marginal cost of building a sustainable building to just a regular building, and we got a whole team of estimating engineers together to do it, the estimate was that to build, at that time, a LEED silver building would cost between 5 and 6% more money. A surprisingly low number, especially when you consider that the estimating accuracy when you're in the planning stage of a building is plus or minus 10, 12, 15%. Mm-hmm. So you can't even tell whether that number is real, but let's assume it's real. We repeated that cost study two more times in 2003 and then in 2006. By 2006, the number was only 3% because the market had in fact responded, and that was to achieve LEED Gold, not LEED Silver. So the understanding of how you do it and what this chart is showing is that you really have to integrate every single aspect of the people involved in the construction project. The subcontractors, the prime contractors, the project managers, the commissioning agents, the designers, you actually have to teach architects how to speak engineering and engineers how to speak architecture, because they are as different as Chinese and Dutch. I think, maybe more. So, but to talk a little bit also about the decision-making process. This is the decision-making process once you have a project. So let us back up a second on the decision-making project. You know, where do you build the project? What projects get the money? And how do you decide that? And we use a very financially based decision model that has many factors which are not purely financial associated in them. And we use, and there are many kinds of these models, expert choice and so on, but it balances energy and water conservation, the mission needs of the client, the location needs of the client, the cost of the project depending on where it's built, and all of these things get balanced. What's happened in the last 5 years is that climate risk is explicitly evaluated in the capital investment, and projects cannot proceed unless the climate risk has both been evaluated and priced. And the pricing is actually easy. The evaluation is a little bit less so, but the science is actually quite good. So it's a relatively long process, about a year long. The big change has been communicating to the people who are proposing the projects all of the different factors that are going to be evaluated, and then putting good metrics for benchmarking and choosing. Because the bottom truth for us is that we have many, many more projects than we have money. And so we have to pick the best projects to go forward. So this whole process is designed to choose among good projects the best projects that we can go forward with.
All right. Well, thank you, Kevin. Any questions or any comments about Kevin's remark? Yes?
Well, perhaps about the cost. It is exactly what Kevin says. In the beginning, they start to estimate, and a few steps later, you find out that the innovative products and systems coming into the market are even much cheaper as they thought in the start. And nowadays, to buy a single glass pane in the most parts in Europe is more expensive as a double pane because it is not standard. To buy a normal boiler is more expensive as a high-performance condensing boiler. And I can continue with that. So as soon as the industry takes up, because they see a market opportunity, it works. But we have to acknowledge that the regulators in many countries, and I don't know if you can agree with me, have some reservation to set higher standards. Because at the moment that they start to formulate higher standards, industry complains that, clients complains it's too expensive. But it is, the price is, as you know, as in the industry is very volatile. If I look to the energy price of a few years ago and the expectation, and we see to look at our current price, how do you do this cost estimate? It is nonsense. So we say we just have to put down energy targets, we have to put down CO2 emission targets, And that should be the start. And all the cost estimates, okay, we need some justification, but don't take it as a primary guidance for regulation. And that should be my advice.
Any comment? No? Okay. Well, actually, I just want to ask you a question a little more about this, the climate risk factor into the cost estimate, because I mean that's what's talked a lot in South Korea and among the industry professionals as well. And I know there are a lot of professionals here in the audience, management side as well, and construction companies who do a lot of cost estimating, of course, and bidding. And President Obama, led this leadership role, saying, hey, from now on, all this federal government should look at not only just the first cost, it's got to look at the life cycle cost, but also it's got to look at the social cost and environmental cost as well to remedy if we don't do these green things. So to me, when I saw that news, it just hit my brain saying, hey, actually the definition of the cost itself, so when we do cost estimating, the cost itself changes by his leadership. And that was great leadership role model that I really wanted to relate to my home country here in South Korea. So going back to you, I mean, when President Obama says that kind of thing, as a federal official, I mean, how your colleagues and your project managers kind of react to those kind of leadership, and how do you see your kind of whole federal agency's reaction on it?
So that's a provocative question. The reaction of most people is, okay, it makes sense, but I have no idea how to do it.
Yes.
And so the way we've addressed that is that I have one person who works for me who that's all she does full time. Mm-hmm. So we have an internal expert who provides advice to every single project team. And we don't do the science. There are other science agencies that do the science. The science is very, very well settled at this stage for climate risk. If you want to know anything, you have a site, you want to know what the climate risks are to drought, we have the data. We want to know the climate risk for heat events, we have the data. For electrical outages, we have the data. For sea level rise, we have the data. The problem for the teams is then, all right, take the data, look at the length of time that we're building the building for, which in the federal government is 100 years. What's going to happen to that site, and what are you doing to prepare for it over time? In some cases, it's not very much. In other cases, it's significant. If you have to build in a place with a meter of sea level rise, you should not actually be putting your electrical equipment in the basement, because it's going to cost you a huge amount. I mean, a not so wonderful example of that is the One World Trade Center in New York City. After Hurricane Sandy, all of the electrical switchgear in the basement was destroyed because it was salt water. Everything was removed. The developer of the site put it all back in exactly the same place. And when I asked the person, did you think about moving it? They said no. And that's the main answer, is just to get people to think about it. And so the reaction is, tell me how to do it, I'll do it. From a engineering, design, project development point of view, nothing is impossible. Some things are difficult. And I think probably the most difficult thing that we face now is passive survivability. What does the building do when there are no electrical services, when there can you use the building? And in many cases, the answer is the building becomes uninhabitable within 24 hours. And so changes, some of that will be changes in technology, some of that will be changes in design. We might rethink the idea of sealing buildings in the same way we do. You know, if you have a building where you can't open the windows, then what do you do after you've consumed all the oxygen in the building? You die. Mm-hmm. And you don't think very well. That's, I think, the biggest change right now is sort of understanding how carbon dioxide inhibits thinking.
Yes. All right. Well, let's move on to next question. So it's to Annie, you. All right. So I know you wrote this book with Hami Global and Dr. Han on this, and this is very well written book, and that title is about sustainable buildings and infrastructure. So I know you are an expert in those areas. So when you called it this book, Sustainable Buildings and Infrastructure, how did you define sustainable construction versus conventional construction? Because you titled this book not just buildings and infrastructure or new buildings and infrastructure. You specifically titled it sustainable. So how did you define that sustainable construction from conventional one?
Well, that's a very interesting question, actually, and it's one I think that we struggle with in this industry. I think that the word sustainable is often used to mean things that are incorrect. Mm-hmm. And so how I would define sustainable construction, I've got this nice graph here that you can look at. There are three factors, I think, that are necessary for a building to be truly sustainable. And so if you look at the y-axis, in the first case, you've got to have a building that actually meets the needs and expectations of its stakeholders, right? We live in a free market economy where you can choose what building you're going to occupy in many cases. And so if we create otherwise green buildings, environmentally friendly buildings, that are unpleasant to occupy or that don't meet the needs of our clients, what are they going to do? They will choose another option that may be worse. So first and foremost, you have to think about what are the needs that you're going to meet. And the onus is on us as an industry to create products that can be competitive in that free market environment from the standpoint of stakeholders. Then there are the more conventional things you talk about when you consider sustainability. And I like to think there are two main factors. One is we've got to make sure that our building has no net negative impacts to natural ecosystems. Why is that important? Well, there are a lot of reasons it's important, but primarily, natural ecosystems are the way we meet our needs and regenerate resources that we as humans rely on. So to the extent that we reduce biodiversity, that we reduce the capacity of natural ecosystems to provide critical services to us, we are cutting off our own survival lines. So in order to be truly sustainable, I would argue that a building has to have no net negative impacts. And in fact, ideally, it would have some positive impacts. And then the third factor that's important to consider is how the building uses resources. And this is important over the entire life cycle of the building and the products that are included in making it. And ideally, a sustainable building should use no more resources than can be regenerated. So basically, we're talking a net zero building. That's the cutoff for sustainability. Net zero impact to the environment, net zero resource use, all while keeping the market happy. Mm-hmm. So that's pretty ambitious. Mm-hmm. And I'm not sure I'm convinced that many of the buildings we speak of as being sustainable actually are.
Okay.
So that, and let me just point out also, if you look at the figure, you'll see that there's an area in the graph that's indicated as green. I think that's ideally where we need to go. We need to create buildings that are regenerative, that actually exceed the expectations of our stakeholders and delight them, that are in demand within the marketplace. And some of our green buildings are starting to show that. They're having market advantage. But they also need to contribute to treating ecological problems and generating new resources. So that's really what we should focus on. And if you switch to the next slide, I put this slide in here because I'm representing kind of an interesting part of the United States, which is, well, let's just say it's an interesting time to live in coal country. So the United States produces a large part of its electrical power using fossil fuels, even still, even with all our investments in renewables. And I included this slide because I wanted to emphasize that when we think about sustainable buildings, we have to think bigger than the kinds of factors we normally consider when we're sitting at our desk making design decisions. We really have to think about social sustainability as well. So this is an example of the kind of thing I see when I go to work every day in Southwest Virginia, in coal country, where a large portion of the people who live in that part of the country rely on that industry for their very livelihood. And so I think it's wonderful that we're proposing a lot of innovative solutions, but in addition to that, we have to make sure that those solutions are accessible to the kind of people who produce the resources that we're displacing, right? So in the United States right now, it's an interesting time because people are very aware that political leadership influences these kinds of choices. If we don't take that into account as designers and provide beneficial social sustainability opportunities for people, then again, we'll have really nice, beautiful buildings, but they won't be used as they could be.
And if I've done my math right, this vehicle that this bumper is on gets about 4 kilometers per liter.
That's probably new off the showroom floor, right? Yeah, if properly maintained. But there are an awful lot of them on the road, and there's nothing that says in a free market economy, if somebody wants to buy that vehicle and they see an advantage to doing so, they can do it. So our solutions have to be better than that.
Any comments on Annie's answer?
Well, you say our solutions have to be better, but what do we have as drivers? Well, of course, we can ask all our people to support our ideas, but that's not going to work. Do you think of regulations, of tax incentives, or pricing? Because these are the 3 things that can work.
I think those are all ways in which a government can take steps to influence the behavior of its citizens. And all of them work in different ways. I think probably we have to choose a combination of those. But just as an example, if you impose a pricing solution to try to deter that car, and we've tried that in the U.S., we've also tried cash for clunkers, where we actually give people money to buy back that vehicle and take it off the road. It's always more complicated than you think it's going to be. And it's really about making sure that that you're not putting at a disadvantage people who don't have other choices. You've got to provide people with a range of choices so that they can make ones within the envelope that they have to work. If they don't have money to buy a Prius, you can't leave them with that their only choice.
I think there's one other factor that works, and that's market demand. And you begin to see this, we talked about the generations before, more people under 35 are living with no car at all and moving back into the cities. And you see this across the country, relying on public transportation and occasional use of cars through some kind of service. In Washington, we have a whole fleet of car-to-go little smart cars. They don't get very great gas mileage, but they're little. So I think the market demand piece is also a component.
So I would raise this as a challenge. What does Uber look like for buildings? What would it look like if
it's called Airbnb?
Airbnb. So instead of our default choice being to construct a new building to meet a presumed need, why are we not rethinking the entire model?
Okay. Yeah, let's just put that thought to the audience. Okay. So I want to just move on to so you do a lot of standards and your expertise in these standards as well. And I just want you to think a little bit beyond the standards. So as we talked, it's not just one single solution for this. It's all intertwined and interconnected, and we have to work together as an integrated, body to solve this problem. So as a standard expert, how do you see, especially in Europe, how do you see this interconnectivity or integration between research at the academic level and the standards, or even maybe codes and regulations by the governments, policies, those kind of interconnectivity and how they work together? And also, if you can say that how your work affects the market, or even you are affected by the market. So how do you see that kind of interconnection among those bodies?
Well, this slide is a little bit mysterious for most of you, but it was, of course, I cannot avoid the word standard, because these slides are just represents the project. I explained that we developed those group of standards around building energy performance. So I narrow now the problem on building energy performance descriptive of describing procedures. And that's what we developed the last 3 years in Europe, and will go out hopefully also to global level. But what we did is, of course, if you connect it to research, we asked the best researchers, the best knowledge people in Europe to come up with these procedures, to write them down, to be the basis of the approaches for our engineers, the basis for the tools you have to develop. And of course, if you, from a standard, develop a tool, there will be new questions. So I look at research and the universities to solve that. But if we don't agree on European, on global level, on the same procedures, on the same way to assess and to reward technology, then we don't have a global market in this field. And the global market is the only solution to have a cost-effective technical development. Look at the products we know in the global market that are really global. They are very, very cheap. And more products we use and apply in our buildings, the building elements, the systems and the parts of systems, should be real global products that can be applied all over the world. And if they are real global products, then there is a big opportunity for industries to be a top seller, you could say. But there is also an enormous possibility for the building designer, the architect, to choose from it and to be sure that the application really works. So I cannot avoid the word standards, I'm sorry. But we standardized a lot of things in the car industry. Cars couldn't be that cheap if we didn't standardize it. But buildings are, if you compare it with cars, are, well, too expensive. Because we didn't standardize. We didn't standardize a lot of things. Okay, I don't want to limit the creativity of the architects. Of course not. But even with standardized technical procedures, you can be very creative. Look at the car industry. Some you like very much, some you don't. and that's because their appearance. Similar you can do with buildings and also with the built environment. You should not think of one building as itself. You should look at the total environment. You should connect buildings in producing buildings, in consuming buildings. You should connect them with microgrids. And connection means standardization. If you don't have proper standard to describe the processes and possible effects of connections, you are nowhere. It is very difficult then, when you really want, it's possible perhaps, but if you sit around the table with different parties, those who are responsible for micronets, microgrids, those authorities responsible for that, and then the builders, the developers, the architects, the system designers, they have to speak the same language. If they don't do, I'm afraid that we can only take very little steps. And if I have seen in the presentation, in the start of this afternoon, that it is very urgent, then we have to take these steps, and we have to allow to use those standardized procedures, and of course to also to criticize them, to make them better, to make our tools better and make our toolbox better, not only on the design desk but also on the workplace where people have to do it. And that's my plea for and my reaction on your question.
Okay, thanks. Any additional comments on his? Well, as a practitioner, as a designer, and also I do some state projects and stuff. So when I was told that here's the guideline or here's the standard you have to follow, and even one universities, they have like this big guidelines, design guidelines for us to read and comply with everything. Always kind of standards and rules and regulations to the practitioners is seen as more work. That's kind of first reaction from practitioners a lot. And I talk with my friends in Korea, and whenever the government starts a new regulation or new policy, oh, there's another one we have to follow. And that's kind of reaction from the market. So how, from your perspective, how would you communicate that standard? I mean, I liked actually your comment that you try to help the market, because without standardization, it costs more and people are lost. But that's why you need the standardization. So kind of, although it's the same standards, it seems like you are presenting that as kind of more assistant tool for the market. So how would you relay that message to the market so they don't react like I am?
Yeah, well, your reaction is well known for me. That's especially when I sit around the table with architects. They say, "Wow, this is 20 pages. Do I have to read that?" I say, "No, you don't have to read it if you don't like. Ask your consultant a nice tool that you can use to do the trick." And that's actually what we expect. We expect that software houses will just use, together, of course, with some consultants and experts, to build the tools. And it is finally the user interface of the tool that is cut in such a way and designed in such a way that a designer of residential buildings or a designer of non-residential buildings or a person who wants really to work on renovation projects can use a tool without reading all the 1,500 pages, because some standards, they contain more than 100 equations. You don't want to read that. And nobody, only a few people we know. And they built a nice piece of software, or they further develop the software they already have, and build nice and user interfaces that are really giving the answers of the questions of the designers, of the builders, and also of the regulators, because all those parties have to get the answers they need. And the only thing we try to do as you could say, as a scientific community, is to build the system under it, because there was, if I see current labeling systems for buildings and for building elements, the basis is very different in different systems. And that is also not good for the market. And it is nice to have a LEED or green building, and I appreciate very much that they are there. But if I go deeper and I look in the system and I see how it is assessed, well, then I have questions that are not answered. And that's what we try to do in those set of centers, to answer those questions. And of course, making the tools, working with it, will raise new questions, and new questions will be answered by research. We have to develop. I will never say it is finished, this is it.
Thanks. Thank you. Well, let's move on to the next two questions, which is for Katz. According to World Bank's recent report, without significant investment into making cities more resilient, the natural disasters may cost world cities worldwide around like more than $300 billion each year. And climate change may push up to 77 million more urban residents into poverty. So the resiliency is more than just responding to the disasters. Its economic impact is huge, and also it's the human right issue as well. So you're from Japan, which is well known for readiness for natural disasters. You have earthquakes, you have typhoon and tsunami even. So you as a high quality construction company expert in that country, how would you see this resiliency impacting your business, and how your business is well prepared for those kind of things?
Yes, we are Japanese. We live with earthquake, so we do lots of research regarding resiliency. I would like to talk about technologies for earthquake and tsunami. We have three-dimensional earthquake vibration generation device at Taisei Technology Center. The researchers are analyzing the structural design and the strength of the building by using this device. Put things on the device and shake, and then they will see how to react. And this device can recreate various kinds of earthquake occurred in the past. For example, the Great East Japan earthquake in 2011. This is Fukushima. The Great Hanshin Japan earthquake in 1995. And the old one, but this is probably California, El Centro earthquake in 1940. So this is our device, and the next one is this is very popular technology. This is seismic isolation system. The installation of the isolation system for the building is very effective to prevent earthquake. We can do seismic input 50 to 70% less than the building with no seismic isolation system. We built more than 250 buildings with seismic isolation systems since 1988. I have a real story. When the big earthquake hit the hospital, that hospital has several buildings, and the building with seismic isolation system had no damage. Even the vase didn't fall from the table. The rest of the buildings without this system have a significant damage. And but I like to sell we'd like to sell this seismic system, but not many clients pay attention. So maybe hundreds or 200s wait, and then we may be hit by the earthquake. So this is not a real story for them. But once they hit, for example, factory, they lost the production and they lost the reputation. It's kind of a risk for the company. The next one is this is the artificial tsunami laboratory in our technology center. In the water system, like a pool, it enables to grasp the behavior and influence of tsunami wave to the land and buildings. The maximum tsunami level is equivalent to 12 meters. This device was developed after the Fukushima earthquake. Next, please. Away from the earthquake, this is the CO2-related subject. I'd like to talk about the environmental management target described in Taisei Agenda to 2016. Every year we provide revised agenda, and the result of our performance is published in the Taisei Corporate Report. I would like to highlight 3 targets related to CO2 emissions out of 7. Response to climate change, effectively utilize resources, promote environmental activities. The first target is respond to climate change. We are the design builder, so for the building design, we need to decrease more than 35% CO2 emission compared with fiscal 1990 level. During the construction phase, we need to decrease more than 45% CO2 emissions compared with fiscal 1990 level. This is our promise to the client. The second target is effectively utilize resources. The final disposal rate should not be not more than 4.0%. The 7th target is to promote environmental activities. To promote 10 or more ZEB projects with clients. Yeah.
All right. Well, that's astounding. Actually, I am surprised that just one construction company has all those kind of facilities and testing beds. It's your own investment. So my question to you is, what drove that decision in terms of investing your own money to create all these kind of testing beds in your company?
Yes, in Japan we have 5 big general contractors. We are very much competitive. So the 5 companies have their own research and development facility. So we are always competitive. So they have 3-dimensional. They have vibration isolation system, but the tsunami system only we have. Mm-hmm. So we are always competitive and to be a good company for the customer. So that's why.
Okay. I mean that's free market that you mentioned. One company does it, and you should be competitive. So that means actually there should be one maybe leader, in that market, leading that competitiveness, and then everybody have to follow. Otherwise, they will not have business opportunities, right? So I'm just asking probably back to you, Kevin, as a government owner, and you hire, CM firms, you hire architects and engineers. So when you select them, how important to you, how important is it for them to present those kind of leadership, especially in sustainability?
That's been the biggest change in our selection process over the last 2 decades. In particular, today we will not hire a team that cannot show that they have already achieved integrated design and construction in the past. 20 years ago, the best we could hope for was somebody who actually understood what we meant. So things have changed a lot in 20 years. We look at, I think that the one problem that we still have is by emphasizing so much the experience of teams, I think we overlook young firms that know how to do it, but haven't had the opportunity on the kind of scale that we're talking about now. And we're actually looking at how we can provide those kinds of opportunities for young firms. And the problem is most of our projects are very large, so risk is difficult to, put, here we have a $200 million construction project, and to put a firm whose largest project was $1 million is a bit of a risk. So, but those are commitment to sustainability, and we look actually at willingness to disclose publicly greenhouse gas and other sustainable indicators as a factor in the procurement. We're looking across the board on that, not just in the construction industry. And all of those things become part of the selection process. Mm-hmm. I think the big change, too, is looking at the construction firm simultaneous with the design firm makes a big difference, and that's something that we only started really in 2009. So it's relatively new process for us, but it's so much better. Our experience is so much more positive that's the way that we're doing everything now.
Okay, good. And Jaap, also, do you observe this kind of change in Europe as well?
Well, yes, there are two movements. I think one is companies who are invited to deliver, design, construct, and also the operation of the building for a longer time, 10, 15 years, which gives them an incentive to think a little bit better what to perform and what is in their interest. And the projects realized so far seems to be quite successful, and it means that the projects are really giving profit for those companies, and the building owners and users are in general more satisfied with the performance. So this model seems to work, but I agree with you, these companies are not the smallest who can do that, because you have to attract the capital to invest in it. But you see also another development where you have smaller companies who see climate change market approaches, and they see, okay, I can develop a product that was very traditional, I can develop it further to a product who can give answers and also have some additional value in comfort, in wellness, and I can also advocate it in a way that it is appreciated by the market. And then you see that a company, and then I'm talking about middle-sized companies, not big companies, they're able to create a profile of a sustainable, responsible part of the society. And they give also extra attention to that, and that sort of approaches you see in more and more middle-sized company to be successful, and that the clients, the contractors, are interested in those parties.
Mm-hmm. Well, I have a little bit more follow-up questions on this resiliency and the economy and the business opportunities, but we now reach it to 4:20, which is actually scheduled for a 20-minute break. So let's have a 20-minute break, and we'll all get back here and start again at 4:40. Thank you.